so much for being here tonight, everyone.
Hi.
Tonight, we are here to discuss the future of space politics. This week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society with more of the human adventure across our solar system and beyond. And because this is a joint presentation of both our regular Planetary Radio show and Space Policy Edition, I'm joined by Casey Dreier, our Chief of Space Policy, and oh my gosh, Casey, I think we filled this whole crowd all the way to the end. We are coming to you in front of a live audience at the Johns Hopkins University Bloomberg Center, which is in Washington, D.C. We're on Pennsylvania Avenue between the White House and the Capitol building. This building is a place, a forum where people come to discuss the policies that are going to shape the future here on Earth and in space. So please give another round of applause to our beautiful hosts for having us here tonight. So this is an interesting show because on the front end, we're going to be talking about some of the amazing science that's going on, especially some of the amazing missions that have come out of the Johns Hopkins Applied Physics Lab. Then about halfway through, we're going to kick into politics mode. We're going to invite some legislators up and other guests and discuss a bit about this moment in space policy and how we see the future of space politics shaping up. But before we get into that, I wanted to ask how many of you are familiar with Planetary Radio and listen on a regular basis? Thank you so much. For those of you who are unfamiliar with the show, for 22 years, this has been going on. It started as a radio show and then became a podcast. Now, we share stories from people from all over the world who are into space exploration. This includes the scientists that work on the missions, but also people who are entertainers and advocates and people from all different realms of science fiction. Many, many people have been on the show throughout its tenure, and it comes out every Wednesday morning. But once a month, we have a special Space Policy Edition that comes out on the first Friday of the month. Can you talk a little bit about Space Policy Edition?
Oh, it's the really good part of space, right? So all the pictures you see, all the spacecraft we see and happen, they're the end product, I think, of the process of policy and politics. At any one of those missions, any one of these images, at the very source, you trace it back far enough, it had to start with some neurons firing in someone's brain, and then those neurons had to influence other neurons in other people's brains, and those, in other brains and so forth. And that's at the reductive level basically what politics is neurons triggering other neurons in a way that ultimately creates something made of metal. And it's always it's a transmogrification of, ideas into, an actual thing. And so the process of how we get these things, why we get these things, and why we do some things and not others, that's what the Space Policy Edition is about. And I think helping us understand why we do it and how it works makes us, ideally, get more of those things. That's space politics. Thank you. Yes, you can cheer that.
Seriously. And we're in a really unique position in order to talk about this. Planetary Radio is produced by the Planetary Society, which is a nonprofit, nonpartisan organization with members from all around the world. We're the world's largest and most effective space advocacy organization, and we work not just in the United States, but around the world to try to shape the future of space exploration for everyone out there so we can know more about the cosmos and our place within it, right? Thank you. We were founded by Carl Sagan, Lou Friedman, and Bruce Murray right after that Apollo era ended. We're actually celebrating our 45th anniversary this year, so it's a really big moment for us. Thank you. But they saw in the aftermath of Apollo, humans had walked on the moon. We were capable of accomplishing amazing things. But after that program ended, there was this moment where there was kind of a lull in congressional will to fund those missions. And in that moment, they saw this opportunity to gather people together to create this grassroots movement to try to support space exploration. And to this day, we have seen that it is still a very powerful and very necessary thing for us all to advocate together to make sure that we can go on these peaceful missions to explore space and learn more about ourselves and what's out there. Primarily, we work to try to learn more about worlds beyond us, to defend Earth from potential impacts from things like asteroids, and to search for life out beyond Earth. These are some of the biggest questions that have ever faced humanity, and together we're hoping to answer them. But in order to do that, we got to get into the politics and advocate for it.
We got to trigger those neurons.
Exactly.
We got to get them going.
So for the first half of the show, we're going to get into the science of the thing. First, we're going to bring out our CEO, someone who I think a lot of you here remember from your childhood, a very beloved figure, Bill Nye, someone who influenced me, and I think many of you out there. Wonderful. Thank you, Bill.
Good to see you. Good to see you. Yes. Look at this crowd, people.
I know, right?
All of you listening on the radio. Look at this crowd.
Well, Bill, we love space. Clearly, you're someone who's super into science, but what is it about space exploration that not only ignites your heart, but made you want to become CEO of the Planetary Society and advocate for this?
Just want to change the world.
No big deal.
No, seriously, you guys. So I don't know how many times you've sat through this, but I took one class from Carl Sagan. And I took it as an elective after I finished my mechanical engineering things. It was cool. So that summer, after I was in class in the spring of 1977, that summer is when the Voyager missions were famous Voyager. They're still flying, yeah.
Still out there.
Big deal. And shortly after that, funding for something like planetary missions was dried up. Sagan, as I'm sure you've heard 1,000 times or more, was just so well-spoken. He was an artist. He was a poet. He was compelling. And so I got the bug a long time ago. And keep in mind that my dad was into it. He was not a full-level amateur astronomer, but he was into astronomy. He had been a prisoner of war in World War II, and they had no lights. And he's got really into the stars. And I'm sure you've all had experiences like this. I remember the moment I first saw the moon through a telescope, and then I remember the moment I first saw Saturn, where it just doesn't look real. And so you cannot help but wonder what's out there. And the only way to get to those places is with extraordinary robotic spacecraft. And the only way that's going to happen is if people like us advocate for it. Otherwise, the reason the Planetary Society was formed was these guys felt that enthusiasm for planetary exploration was very high among the public, but government support of it was not. Of course, that doesn't happen now. Of course, that's irony, everybody. So it's a problem once again more than ever. So I am just delighted that you guys took the time today to come to Capitol Hill. How many people went to Capitol Hill today? Those of you on the radio.
Applaud those people.
Thank you so much.
Those of you listening on your phone or podcast or on the radio, Sirius XM or what have you, notice that every hand went up in this big auditorium because people are enthusiastic about it. So I am proud to know you. Thank you so much for coming. And those of you on the podcast, thanks for listening. Back to you.
Now, up on the screen right now, you're seeing an image of our advocates from this morning going to Capitol Hill to go talk to the legislators about NASA funding. This thing happens every single year. This is the largest crowd we've ever brought out. And the reason we do it is to make these beautiful discoveries. There's so much out there waiting to be known, and we've seen some really wonderful things happen in recent years, and we're hoping that we can continue to keep the funding in place so that we can go out there and fund the missions that we have lined up. So I'd love to bring out our next guest to talk a little bit more about these missions. We have Nancy Chabot. She is the chief scientist from the Johns Hopkins Applied Physics Lab. Please give her a round of applause. Thanks. Nancy, you have worked on so many different missions in your capacity at APL. I know that there's many things that happen there, but the space exploration parts are my favorite. I wanted to ask you, what are some of the missions, and I know it's a long list, that you've worked on?
Well, I really got my start working on Messenger, and I know there's some other people out here who worked on Messenger, so I want to hear you now, of the Messenger people.
Any Messenger heads
Messenger crowd
out there?
There we go. They snubbed him there. So it was the first spacecraft to ever orbit the planet Mercury. I mean, it's amazing to think that this planet, right in our own backyard, we had only seen 45% of it before this mission. Like, we literally didn't even know what this planet looked like. And that's what I love about planetary science, is you ask such basic questions. What does this planet look like? What is it made out of? How did it get here? And that's exactly what Messenger did. And so,
can you do the acronym?
Oh no, that's so tough. It's Mercury, exploration, space, environment, ranging, geochemistry.
Woo! Woo!
Oh, that's probably wrong. It is a little tortured acronym, but you know, it is NASA. So.
Well, and he was the god of Western Union. That may be an older reference.
It definitely makes sense for the planet Mercury, and they just forced it a little.
Yeah, it's good. I wouldn't change the thing.
This is something I love about planetary science, though. You were exploratory science. You could put a camera on a box with some energy on it, a battery, and you will learn something new. And you do a lot more complicated than that, but that's like the essence of it. You could just go and look for the first time.
We do a lot more complicated things than that. But no, it's true. Actually, at APL, we just launched the EASY mission, which is like 3 CubeSat size. So they're like the size of a shoebox. And right now, they're going around the Earth every 90 minutes, like looking at how the auroras form, how our upper atmosphere interacts with the space environment. And the fact that you can do that in a CubeSat size, and they don't even have propulsion. They just sort of like go and with the drift and the drag in order to make these measurements. So yeah, I mean, science is amazing, and I think it's just so fascinating that we're constantly finding new ways to explore.
We're really fond of CubeSats at the Planetary Society because it's what we use to create our LightSail and our LightSail 2 mission, which is the first fully crowd-funded space mission in history.
And only.
Honestly.
So kudos to you guys. You know, that idea, you can argue, goes back to Johann Kepler, 1607. Who just reasoned that since the comet's tail, this would be the comet that later became Comet Halley. I grew up calling it Halley's Comet. Comet Halley, he saw the tail always pointed away from the sun, and he reasoned that there must be something about sunlight. Humankind will one day sail on sunbeams the way we sail the winds of the ocean.
We actually used solar sailing on Messenger a little bit at the end because we ran out of all the fuel and we were trying not to crash for as long as possible. And
you guys
literally
got 5 extra orbits or something, right?
Yeah, because of it. So
here, tell them how it worked.
Just like you said, pushing it away and the pressure that comes out from the sun.
So sun, it's not solar wind. I just always disabuse people. It's photons have momentum, even though they have no mass. Whoa, dude. No, it's really amazing. It's amazing. And so you guys got 5 extra orbits exploiting
solar sailing.
And
a little bit different. It was with the wind too, but the same sort of thing. I mean, it's just
because you were so close.
We were going around Mercury trying not to cry, trying not to die and crash into the planet. And there was some tears, but they were tears of joy. All good things must come to an end, I suppose. Yeah, a little over 4 years when it was supposed to last 1 year.
Right.
I remember I was a little kid reading this science newsletter. Remember when, my understanding, it was radar that discovered that Mercury was not 1 orbit, 1 spin, right? It's 2/3 or one of these things?
Yeah, it's a 3-to-2 spin orbit resonance. So it's a spin orbit, so it spins for 3 times for every twice that it goes around the sun.
It's an eigenvalue or one of those things, right?
Yeah, it's like a tidally locked like that. It is very interesting if you were on the surface of Mercury because there's certain points where the sun would actually move backwards in the sky for you. So, yeah, I mean, that's just what's so fascinating about all these alien worlds, right? I mean, it really is like not just science fiction. The worlds in our own solar system are just as fascinating.
So you guys, I'm on the board of the Planetary Society, and when I first started going there, and these guys and gals are talking about going to Mars. And they're serious. It's like, going to Mars? Yeah, we're going to send a spacecraft to Mars. What are you talking about? That's amazing. We take it for granted now.
My first rocket launch was the DART mission, the Double Asteroid Redirection Test. This is a double asteroid system, Didymus and Dimorphos. And we went in there and crashed a spacecraft directly into one of these. You worked on this mission. Why did we do this?
Yeah, we did this because, asteroids have hit the Earth in the past and they're going to hit their Earth in the future. This is kind of a cosmic inevitability, but they can cause a lot of damage if they do. And it started back in 2015. That's when we started working on DART. And there was over 1,000 people that contributed to DART from all those years, in order to get to that moment to autonomously crash a spacecraft into a small asteroid that had never been seen before when you're going 14,000 miles per hour. And, letting 1 million people watch worldwide while you see if it works. So, yeah.
Who do you ask to do that? I got an idea. I want to smack an asteroid. Where do you go from there? How do you convince folks to pay for it?
It's really interesting because the science community kind of is the one that is the place for most of these first ideas. Is like, you have an idea, but all of this is so much bigger than any one person. It's really not like the one person with the one brilliant idea. It's like you share it, you talk it with other people, you discuss it. It becomes bigger than any one person, and you get a consensus together. And then with that consensus, you go and you advocate in order to make these things happen.
So when somebody had the neurons firing, 2015, we're going to find an asteroid to smack into. You hadn't found this double asteroid, right?
So this double asteroid system was discovered actually in the 90s. So we knew it was a double asteroid from telescopes.
Oh, I see. But it hadn't been selected. Let me put it.
So these asteroids aren't a threat to the Earth, just in case that wasn't clear to anybody. We didn't actually save the Earth. It was a test. The T in DART stands for test. Yeah, but what really enabled it was the double asteroid system, because what we did is we crashed into the small asteroid that goes around the larger one, so you could measure that deflection, as compared to if you had to measure the deflection going all the way around the sun when you've already destroyed your total spacecraft. So we used telescopes on Earth in order to see how much we had deflected it. And that's why this asteroid system was in the right place at the right time in 2022, to have those telescopes make that crucial measurement.
It's like rocket science. And so after you guys hit it, it sped up, right?
It orbited closer to the body than it used to, and so actually its orbital period went around faster than it used to. So it changed it by 33 minutes.
That's counterintuitive and cool.
Well, we hit it head on, so you can kind of imagine you crashed into it, changed its.
And the other thing about it was that you couldn't steer it from here. It's too far away, right?
That's correct. The whole thing was autonomously guiding itself for the last 4 hours. And at that point, you couldn't even see the smaller asteroid that it was crashing into. And so it had to autonomously detect the larger asteroid and the smaller asteroid, and then fire the thrusters in order to not hit the larger one and hit the smaller one, and do all of that on its own. And so there was a lot of navigation programming that went into that. And it's very applicable if we did have a threat to the Earth in the future, where we wanted to guide a spacecraft in to change the future path of an asteroid that might be headed towards the Earth.
Yeah. And it worked better than you thought it would, right?
It worked, I don't like to say better than we thought it would. We thought it would hit the asteroid, and it did that. But what we got out of the asteroid, the reason we needed to do this on a real asteroid is because asteroids are complicated. They're actually like this weird pile of rocks that are loosely held together, and it made a huge amount of ejecta. The tail at one point was over 70,000 kilometers long, and like people around the world, telescope groups, schools were watching this tail for months and months after the fact. And that gave it an extra push. So it actually did work better than if you had just brought the spacecraft in, because that recoil effect of the ejecta, of that giant tail, moved the asteroid even more than just the spacecraft on its own.
So the thing, this DART smacked into it, then ejecta, rocks, gravel went off the other direction, which slowed it down even more.
Yeah, which gave it an extra push. So it's like the asteroids are helping you, right? So this makes it a really promising way that if we did need to deflect an asteroid in the future, something like DART might be what you did.
Pretty soon we're going to have...
Except in space, there's no sound.
Pretty soon we're going to be able to see more of the aftermath of this, because the European Space Agency is sending their Hera mission out there to see the aftermath of this. So we'll get a real understanding of how much this technique, this kinetic impactor technique, can potentially help us save all life on Earth and all the creatures here in the future, potentially. But this is a mission that's already occurred. You can learn more about it online. I know a lot of you in the audience are probably curious about this giant spacecraft model up here, and this is something This is an actual test model of the Dragonfly mission that is going to be going to Saturn's moon, Titan. Now, why is Titan such a fascinating target for us to go to, and why are we sending a quadcopter?
Because we can, is the part to the second part of that. But
Hey, no kidding. I'm serious. Is this model, is it a quadcopter or an octocopter?
it's an octocopter, I think.
They really are.
technically.
They're 8
But you can just use, say, rotorcraft, and then that covers all your bases. So you're good. But yeah.
Well, go ahead.
So why are we doing this? So yeah, the model that you see up here is one that is being used for development. It's actually a half-size model. So the one that is going to fly around on the moon of Saturn, Titan, is actually about the size of a car. And it's nuclear powered, which you see coming out of there. So it's a nuclear powered car-sized octocopter that's going to fly through the skies of Titan, which is a moon around Saturn. And Titan is so exciting because it has an atmosphere, it has liquid water under its surface, it has carbon-bearing molecules, and it seems like the carbon compounds in the liquid water have reacted with time. It's like a laboratory for prebiotic chemistry right here in our backyard. Sort of the chemistry that made complex organics and molecules literally the stuff of life. And how these molecules get made on Titan, that's what Dragonfly's gonna fly around and see, fly from dune to dune, sample the surface, make those chemical measurements. I mean, that's gonna have to use a lot of autonomy too, because you can't just, fly an octocopter on a moon of Saturn, by joysticking it.
You just used a phrase I'm unfamiliar with, dune to dune.
Yeah, dunes.
So we've seen dunes, sand dunes.
Oh, yeah.
Yeah, they're sand dunes, but the sands are made out of organic compounds. So they're like these organic, rich dunes. But yeah, they're blown by the winds because it has an atmosphere. Actually, the atmospheric pressure of Titan on the surface is only slightly more than the Earth, about 50% more. So it would be like maybe being 50 feet underwater or something like that. The gravity is much less, though, about a seventh or 14%. And so it's great to fly. Supposedly, if you could get through the really, really cold temperatures, humans could fly if you put wings on and flapped your arms, is what people say.
I mean, how cool would that be?
I want to try that.
When you guys...
Well, we'll go with the octocopter first, just
So when the octocopter, when the 8-bladed thing is flying on this model, does it have to be held up on a tether or something, or is there enough air on Earth for this thing to fly around?
There's enough here. It's more the gravity that you have to compensate for, but they've been using this one more in wind tunnels testing and also to test out that navigation that has to happen all autonomously, flying around on dunes here on Earth, dune fields, and like using the cameras to sense what that's like and make sure you don't crash and stuff like that, because you want to make sure you get that out of your system before you go all the way to Titan.
How much did we learn using Ingenuity on Mars for this thing?
I think it's related, right? I don't think it's a direct one-to-one thing, but the expertise in the community, I think that's what's interesting, too, about space science. None of this exists in isolation, right? Science and technology for space is not really separate than science and technology for other uses, right? As all of this grows, you can apply it to a whole variety of different things, including space science.
There's so much left for us to do. If we want to accomplish these missions, we need to be able to advocate together in order to do it. And I cannot wait to learn more about Titan and all the organics and its hydrological cycle. There's so much waiting for us left.
When are we going there? I say we.
In a few years, right?
Not the octocopter in July of 2028 is set for launch, and then it will get there in 2034.
2034, stay tuned.
Well, it's time. We've given you guys a little taste of some of the science that we're trying to promote out there. But it's time for us to kick into our space policy version of this. So please, can you guys give a round of applause for both Nancy Chabot and Bill Nye, the science guy?
Thank you. Our next guest is Representative George Whitesides from California's 27th District. He just assumed office in January. Prior to that, and I'd say this is probably unique for members of Congress, he was CEO of Virgin Galactic for over a decade. And before that, he was NASA's chief of staff under the first few years of the Obama administration. And also, I think rare for Congress, he co-founded Yuri's Night, which is a global celebration every year to celebrate the first human in space.
Right.
Welcome, George Whitesides. Congressman, are you the first member of Congress to have won a NASA Distinguished Service Medal? Is that true?
Gosh, I don't know. Probably not. There have been a bunch of great astronauts over the years, or a few astronauts who've been in Congress. I'm pretty sure that Mark Kelly has something.
Probably.
That's a good point. I guess he has flown into space as well.
Yeah, multiple times.
All right. So, Congressman, we have recently joined Congress. Congratulations, by the way, for assuming office. You're now representing a whole district. You have your own, I imagine, positions on space policy, having worked in the field for so long. Now you also, though, have to be a representative. How do you balance that? I'm very curious where does your own personal desires as interests as a policy expert end, and where does your responsibilities or prioritization work for how you represent the people that elected you into office?
I'm honestly still figuring it out. I think that at heart, as many of you know, I'm all about science and space and discovery and inspiration and the next generation. And I think those are things that, are both important for our district and important for the future of NASA and important for the future of other scientifically focused agencies. And hopefully it's all consonant. There will be particular things. We've got the NASA Armstrong Flight Research Center to the north, and we've got JPL to the south. Neither of them are actually in my district, but a lot of people who work at both of those places live in my district. And so I'll make sure to do what I can to help those folks. But at the top level, we are in such a crisis right now. We've got to protect those things. All of those things are under attack right now. And my hope is that I can use the position that we've got, as vice ranking on science and on armed services to fight back and to push back against the wave of anti-science and anti-discovery and innovation attacks that we see coming.
You mentioned two things, armed services and science. Those are committees. You serve on those committees. And for those of you who aren't as familiar with just how Congress works, what is the importance of being on a relevant committee, like being on the science committee? And how is it distinct? Because in these committees, you're not doling out the dollars. You're not appropriating money. What is your role, and how do you even set and decide on, as a committee, what the policies, in this case for space or science, should be?
Yeah, and we're figuring that out too. I think in a general sense, both of the committees that I'm on are authorizing committees, right? So in theory, the way that Congress, for many of you in your home lives, in your households, you decide what you're going to spend on and then spend on it as sort of one family unit. Congress has taken that and divided into two parts, right? One is sort of here's how we're going to prioritize it through the authorization process, and then, here's what we're going to spend money on through the appropriations process. Both of the committees that I'm on are authorization. But I do think that, there is an opportunity to highlight stuff, particularly for armed services. The NDAA, which is the National Defense Authorization Act, has been passed every year for over 60 years. It's the only bill, not even the budget has passed, not even the spending bills has passed every year. So it's an opportunity to make clear our priorities when it comes to space in both of these domains. And I hope to use my position on those two committees to be a strong voice for science and for space.
We have obviously a divided Congress, and you're in the minority at the moment as a Democrat. We did invite your Republican colleagues. They weren't able to make it, unfortunately, but I think space is a bipartisan activity. Do you still agree with that?
Yeah, I definitely do. I've gotten to know Mike Herodopoulos. He's the new chair of the Space Subcommittee. Just talking to him half an hour ago on the floor. We were talking about things that the Space Committee, would do hearings on, and obviously he represents Cape Kennedy, Cape Canaveral, and so has a strong interest in a strong NASA. And, hopefully we can work together to protect the agency. We need to make sure that we get a confirmed administrator as soon as possible. That is super important.
And Casey, I do want to point out that I believe our next representative as well is able to join us.
Oh, should we welcome Representative Chu to the stage?
Let's give it up for Representative Chu.
Thank you so much for being here. You represent California's 28th district, which includes a little place some of you may have heard of called NASA's Jet Propulsion Laboratory.
That's my district.
Congressman Whitesides and I were just talking about the process of setting policy in Congress and how that works for such a diverse and broad body of individuals. How do you approach bringing your desire to kind of represent JPL's interests, but also your broader national commitment to space in this large body, I'd say?
Well, I have the honor of representing JPL as well as Caltech. So I have some pretty amazing institutions that I represent. But I have to say that our efforts in space is definitely bipartisan. I mean, I have seen huge interest on the part of Republicans and, of course, us Democrats in making advancements. And there is, in fact, very enthusiastic support, I would say. And that's why I became the co-chair of the Planetary Science Caucus. It is bipartisan. Yep. We had 20 members in the last Congress, but we have to recruit them up again. But Don Bacon is my Republican co-chair.
Yes. Thank you, Don Bacon, who unfortunately couldn't be here tonight as well. Do you think, and this is to both of you, do you see space as an opportunity not just to share bipartisanship, but to build maybe some trust that could extend to other parts that are maybe more divisive in politics? Does that serve as a concentrating way of building relationships on space issues?
Well, Don Bacon and I were very strong on stopping the JPL layoffs to the Mars Sample Project. And so we worked together on that. He believed, as I did, that it shouldn't be cut. It was originally set for $950 million, and it was cut down to $300 million, which resulted in the first layoffs of 530 from JPL and then 300 in the second set of layoffs. So it was very alarming to us, and it was very alarming to see all that expertise go out and get snatched up by other entities. So, yes, there's bipartisan sentiment on not letting that happen.
Yeah. You have parochial responsibilities to the district, to the people who elect you and expect you to represent them. How do you balance that against, space as a national interest? I mean, and it represents us into such a broad sphere of interest. How do you try to say what is best for the nation and what is best for your district? And how do you walk that line to bring those two together, to align with your needs of your constituents?
Well, I always remind the public about the amazing discoveries that have been made because of space exploration, such as the camera phone. Mm-hmm. All these inventions that had to come about due to the struggle to survive in space, freeze-dried foods, scratch-resistant glasses. These are things that have greatly advanced society. But I guess what I truly find gratifying is the fact that every time there's a launch, like the Perseverance rover launch, the whole community gets behind it, and especially the young kids. The young kids are just glued to the screen as they see the launch taking place, and it just generates so much excitement in STEM and science and space. It just is instrumental in getting our whole next generation of scientists.
Yeah, I agree. I think that's a good applause line.
I know, right? And I know, too, that we have limited time with you, Representative Whitesides. So thank you for being here tonight. I know it's a really dynamic situation, and they're actually holding some votes in Congress tonight that have made things very interesting and complicated. So I wanted to ask if you had any last questions for him.
Oh, absolutely. I mean, what are you looking forward to, Congressman, in the next couple of years that you get to work on now in terms of space issues? And what do you hope to achieve through those?
So last week I was out in LA, and I was part of a CODEL, which is a congressional trip, a congressional delegation to LA area space companies. And so we visited a bunch of them, and we also visited some government facilities as well. And it is such an exciting moment right now. The dynamism that you see in the private sector. We visited a company called Impulse Space, which is founded by a guy named Tom Mueller, who, as some of you may know, helped design the Merlin and the Raptor engines. And America is leading the world. We have the opportunity to embark on the most incredible era in space exploration. And we just can't screw it up, folks. We are doing great things. We're going to be able to, for 20 years, I've been talking about small sat planetary exploration, and so is Bill, and so is the Planetary Society, right? And JPL has led the way on a lot of that to Mars and other places. And we've got lunar exploration going with commercial companies, and often they don't fall over. They're that's probably unkind, but we have got an amazing opportunity to explore the solar system in a way that we never have, at a diversity of outcomes and destinations, and it boggles the mind. We can do, in situ research on potential biology on the icy moons and on Mars and all over the solar system. We can't screw it up. And so, really what I want to focus on is, in the near term, preventing harm to NASA's institutions, right? All this hoo-ha about cuts, about, moving NASA's headquarters. I mean, all this is distraction and ultimately potentially damage to what is one of the most noble pursuits of humankind, which is the exploration of space. And so that's what we got to do, and that's what we'll fight for. Yeah.
Right. Congressman Whitesides, thank you so much for joining us tonight.
Thank you so much. We'll be right back with the rest of Planetary Radio live from DC after this short break.
Hi, y'all. LeVar Burton here. Through my roles on Star Trek and Reading Rainbow, I have seen generations of curious minds inspired by the strange new worlds explored in books and on television. I know how important it is to encourage that curiosity in a young explorer's life. That's why I'm excited to share with you a new program from my friends at the Planetary Society. It's called the Planetary Academy, and anyone can join. Designed for ages 5 through 9 by Bill Nye and the curriculum experts at the Planetary Society, the Planetary Academy is a special membership subscription for kids and families who love space. Members get quarterly mailed packages that take them on learning adventures through the many worlds of our solar system and beyond. Each package includes images and factoids, hands-on activities, experiments and games, and special surprises. A lifelong passion for space, science, and discovery starts when we're young. Give the gift of the cosmos to the explorer in your life.
Congressman Chu, now we have you all to ourselves to talk all about space. You mentioned something that really struck me, which is seeing how kids engage with space and seeing that excitement. I myself, my whole life changed when I saw a rocket launch, and I was 30 years old. And I think I think other people may resonate with that, and I think there is something truly spectacular about it. And so when you think about NASA as a public institution, and you've been a public servant now since, you've been in Congress since 2009. What do you see as the role of a public institution, and what do you think it owes back to the public that is unique or so important to serve it to us?
So NASA, of course, directs the kind of projects that take place at JPL. And JPL has been so open in getting people to visit its campus. And when they do the open houses there, it is just incredible to see.
So much fun. Cannot find parking there anyway.
Absolutely. And the subject areas just range from weather to geology. But it's so important for us in Congress to continue to explore space so that we can, in fact, give back to our society in answering questions. For instance, with the Mars Sample Project, it is to find out whether there was life there. Yeah. On Mars, and if so, what happened to it? Mm-hmm. What happened to water, if there was any, on Mars? So there are very, very key questions that can be answered.
Yeah, I am so struck by the fact that we have a system in our country that starts with questions. So we say, what is happening here? And by here, I mean 100 million miles away. And what happened there? What happened to the water? Was there life? And instead of just leaving that floating in the air, we have a whole institution and a whole system designed to say, well, let's figure it out. And they start with the questions and work backwards. How do we answer those questions? And then they say, okay, and here's how we design the things to make those answers possible. And then we get all the people to figure out how to get those things to the place where they need to be. That, to me, when I've gone to JPL and marveled at the capabilities that they have there and other NASA centers around the country, it truly strikes me as something I don't see anywhere else. And that, to me, is what I think this unique aspect of space and the unique aspect of NASA as a public program, that if it was gone, it just wouldn't be replaced because you wouldn't be starting with those questions.
Exactly.
So how do you make those questions happen? I mean, this is where you come in, right? How do you, when you engage your colleagues, both in your same party and across the aisle, do you see this general, we have, I think, a general positivity towards NASA, right? How do you turn that towards actual action? Because a lot of people like it, but who will go, to bat for these particular issues? Where do you see that really motivating people when you've engaged with them on these issues?
Well, that's why a Planetary Science Caucus is very important. It brings out the people in Congress who have the most interest in planetary issues. And so we can gather them. Of course, there are the exciting launches that happen in Florida, as well as the launches that we've had there with JPL. And you just cannot help but be swept up by the excitement that's there. When the Perseverance rover landed, I mean, we were all there in the control room looking at it, and then the incredible excitement of the scientists as the rover landed exactly as it meant to.
Yeah. Is there something about that experiential part? Do we need to fly more members of Congress to launches or to rooms? Or do we need to land more? I mean, is it true? I mean, though, like the experience of it, you felt that, and it's almost reacting to the other people. Is that contagious? Does that influence how policy happens at the end of the day? Because we're all people, members of Congress. We all feel things. Does that come into this for a lot of people?
Yes, and that's why it is important to invite the members of Congress to the room in which you can see all this happening. They also invite VIPs, like I'll never forget, Morgan Freeman was there.
Really?
Astounding celebrities like that were there because they were also excited about what was going on. So yes, it is infectious, and it is highly beneficial to invite the members of Congress there.
It's a great equalizer, in a sense. We all get to experience something profound together that way.
Exactly.
Let me flip it around. We just had 100 people come from all across the country today to meet with their elected officials here in Washington, D.C., to talk about why they love this. What is that like, as that person that they come to? What is the role of people? Is it valuable that they do that to begin with, that you hear that from them, your constituents?
It's absolutely important for you to be able to get out there with your members of Congress and to talk about your own experience with space exploration, to talk about how you were excited by it and inspired by it, but also the necessity for ensuring that there are the congressional funds for space exploration. So yes, that is very important to convey to each of the members of Congress.
You heard it here from an actual sitting member of Congress. This is important work to do. But I mean, it's so, I'll just, one more follow-on on this, and I know you have to go, but this is so important to me too. When you are a representative, I always go back to that word. You are representing people in your district. And is it too much to say you want to hear from them, I imagine, on these issues? And, we push back. I think the biggest challenge that I face in this role and my colleagues face is convincing people that this is not a purely cynical exercise, that the act of going and participating and sharing exactly what you just said is important. And that doesn't mean that they're going to drop everything tomorrow and change their complete view on things, but it's important we hear this. And to just turn it back to you to fill in a little bit more, when you hear these stories, when you hear this information, even when you hear it from your staffers who meet with them, how did that comes in? Tell me how that influences how you approach these issues when you're hearing from your constituents. How does that change your mind on things?
Well, when you're a member of Congress, you get requests for meetings from many, many groups, many different kinds of groups representing different issues. So they are all vying for your attention. And that is why it's important to get your voice in there and also to make your voice compelling. So to talk about how space exploration has affected you and how it's changed your life, that does make an impact.
A great communication tip. Congressman Judy Chu, I want to thank you so much for joining us here today. Thank you to the Congresswoman.
Well, I believe we have a few minutes before our next guest comes out here, but I got to go to the Day of Action for the first time last year, and Judy Chu is my representative, and I got to go into her office and actually be there with her. And you were one of the people that trained me to do this. What is it like to empower people to do this? And what do you think are the biggest messages that you would give people who might be intimidated to try to take on some of this work?
Intimidation is real.
Yeah.
I mean, the first time I went, you're walking around in a suit, which I don't normally wear. I'm carrying something there's people walking around very important and fast in various things. Big, grandiose buildings, and everything, all the symbolism weighs on you. And as I was doing it, I realized it's actually really set up to have me here, or anyone here. And it's this truly earnest and ideal attempt to be ideal, right? That the system itself wants you there. That everyone has the right to be there as a citizen of the United States. And that is truly, it's true. And I think a lot of the people who went and advocated today on the Hill realize as they do that you become comfortable after your first meeting. I'm now the person walking around all important in the suit, right? And because you gain that confidence, and they want to hear what you have to say. That's why I was asking Congresswoman Chu about being a representative. Their job is to literally, it's worth pondering that word sometimes. And the system we have in this country, it's at the core, it wants you to say what you believe. And I think saying that about space is so important, because if you don't say it, they're not getting it from necessarily anyone else, or if they are, you have no idea what they're saying, right? I want you to say the good stuff about space, and that's why we do it.
And I think a really important piece of feedback I received today was not just that you are welcome there, but you deserve to be there, right? We deserve to go speak to them about this, especially about something that we love so much.
Our next guest is Antonio Peronace. He is the Executive Director of Space for Humanity. He has worked in many different roles. He was at the U.S. Senate and U.S. House, working in communications and strategy. He worked at the Environmental Defense Fund. And now he leads Space for Humanity, a nonprofit that sponsors people, leaders in their community, to go to space in order to see the overview effect. What a cool job. Right. Please, everybody, welcome Antonio Peronace. So how do we get to space? How do I get to space?
How do we get to space, dude?
You said community leaders. I see also here podcasters and chiefs of space policy. Is that right?
You've nailed it. That's who we're looking for. Has anyone here ever dreamed about going to space? Anyone here want to go? No, it's a great privilege to do that, to be dedicated to increasing access to space for regular people.
And you've succeeded. This is not a theoretical thing.
No, that's
some of the folks you've sent into space.
Yeah, we to date we have helped support 6 people going to space. Thank you. No, hold your applause. There's more coming. More insights coming. Our first citizen astronaut, that's what we call our citizen astronaut program at Space for Humanity, was Katya. Katya, incredible individual. She became the first Mexican-born woman to go to space, which, thank you. It's incredible to think that we had that honor, that we were able to do that. So Katya, born in Mexico, immigrated to the United States, head breadwinner in her family, working at McDonald's, put herself through school, became an engineer, and I often say we were lucky to find Katya, really. So Katya, like many thousands of others, went to spaceforhumanity.org, applied, and we rated her along with everyone else against a rubric. And folks ask me all the time, like, what's a secret? How can I? Well, first of all, it's not like I'm picking anybody. We have an international team of teachers who put eyes on every application, and we're looking for folks who are going to make an impact. If you're given this gift, it's not really about you or the Katyas and so forth. It's really about what are they going to do when they get back. And so for Katya, she went up on a suborbital, Blue Origin suborbital, and since coming back has just been a force of nature. She had a Barbie doll made after her. She was on the cover of Vogue in Mexico. She was in National Geographic. She meets with elected officials, and I can tell you, gosh, she now sits on my board, which is why I have to talk so nicely. But Katya is an incredible human being, and I was with her in Mexico City late last year. She had her first annual Space Congress. She started her own foundation to encourage young women to get into STEM. Yeah. And And I was on stage with her, and she had 1,500 people in the audience, mostly young people, hanging on every word. And I remember getting off stage with her. I'm like, you created engineers tonight, you created teachers, you created physicians, scientists, astrobiologists, the whole thing. And that's, for us, that's what space does. It's a force multiplier.
If anyone here has listened to Space Policy Edition in the last year, I think, I've been wrestling with this idea of the motivations for why we go to space.
Yep.
And what it does. And that we talk about space, particularly in policy world, and this kind of not necessarily dry, but a little dry, practical, quantifiable. We're counting this and this kind of economic return and counting STEM majors and so forth. And that's all real and good.
It's exciting for us.
But it's particularly for people I love budgets. It's so cool. But I think why we do this, and I think you heard this from Congresswoman Chu and Congressman Whitesides, and from Nancy and Bill and Sarah, and probably from me, that there's a deeper part of it that's harder to express. And I think what's so interesting about your organization is that you lean into that almost exclusively, right? Yeah. That merely by going into space, you are yourself changed by it. And then you bring that experience. And it's not that, I went into space and this was the such and such like ISP and I did this, level of experiment, blah, blah, blah. Those are all good. But they're talking about what it was like to go. And that's what people seem to be responding to.
Yeah, I remind myself often of the importance, the value of seeing yourself in a position like that, seeing yourself in space. That's what we're really in for. What you're describing is the overview effect. I don't know, how many here know what the overview effect is? Yeah. So, yep, that is the name for the cognitive shift that happens when an astronaut goes to space and sees our home planet looking down on it for the first time. They see this thin layer of atmosphere, they see there's no borders, and they focus on our interconnectivity, the fragility of our home world, our place in the cosmos, as I hear you talk about, Sarah, a lot, and Bill talks about as well, and they come back changed. And imagine if you're able to apply that to different countries, cultures, and communities. So we sent, Katya was our first. The second was Sarah. Sarah was the first Arab woman, the first Egyptian, and the first woman from the African continent. Applaud all you want. I could talk about this for hours.
That made me super emotional. My family on my father's side comes from Saudi Arabia, so there's not much representation for Arab women in space, and that really touched me.
Number 3 and 4 that we sent up, Keisha and her daughter Anastasia, the first and only mother-daughter duo to go up, and the first Antiguans. And I can tell you, number 5 was very special. There is an excellent documentary called Space Race on Disney+. And one of the main individuals they feature is an individual named Ed Dwight. And Ed Dwight was chosen in 1961 by President Kennedy to be America's first black astronaut. He faced quite a bit of resistance. He was told, he was a decorated Air Force captain, told the country's not ready, we're not ready, you're not going to be an astronaut. Sure enough, President Kennedy was assassinated. The next day he reported for duty and he was transferred to Germany. And he had to give up on his space dream. And he changed his pathways. He became a world-renowned sculptor. And he waited. He waited 61 years until, with Space for Humanity's support this past May, he became the oldest individual to go to space at age 90. So do not give up on your dream.
Yeah, I had such a beautiful conversation with Ed Dwight and Leland Melvin.
Yep.
I brought them on to talk about the space race. So if you want to know more about Ed Dwight's story, I really encourage you to watch that documentary from National Geographic, also on Disney+. But also, you can listen to the podcast as well and hear more of their stories about what it was like in that moment for them in time. And I'm really hoping that we can bring Ed Dwight back onto the show in the future.
Let's do it, absolutely.
To talk about what that was like for him, because what a realization of a dream, not just for him, but for all the people who saw themselves represented there, that had that dream pulled away from them and had to wait so much longer to see themselves represented in that journey.
And that's really the key for what we're doing, is we're preparing folks for that dream, that realization space. That whether it's Ed Dwight as a symbol, we also supported Emily Calandrelli going up. Next person we're supporting going up is Amanda Wen, going to be the first Vietnamese woman in space. She's part of that first all-female crew you may have heard about. She's going up there with Katy Perry and Gayle King and others. And Amanda knows this. It's yes, she's an incredible story and figure, but it's about who can she inspire.
Yeah. The other aspect of this that I think is very interesting is that all of these flights, right, have been on Blue Origin. Is that true?
No. 1, 2, Blue, then Keisha and her daughter were on Virgin Galactic. We are vehicle agnostic. Yeah.
commercial providers.
But commercial providers, yes.
And that itself is an outcome of a policy decision.
Yep.
Commercial space, as we know it now, didn't just spring into life out of nothing. It was a focused policy beginning in 1984. NASA started putting serious money into it in 2005. And it created not only the financial support, but also this expectation or idea that multiple companies could exist and this new markets could open up. And I think, again, your organization is a really novel use of that, in that you're using these new systems to increase access to space for people who would normally never have that. But also, you have this completely new set of tools available to begin with. Again, this doesn't just happen.
No.
You have to make it, but then how it's used becomes uncertain, right? You have all these new possibilities before. Antonio, you worked in House and Senate.
Yep.
You have seen a lot, you know a lot of people. How have you seen space talked about change over time?
Yeah.
Because it's, it went from, I think, 20 years ago, the way that space was conceived of particularly in our politics, is very different than we see it now.
Yeah. I mean, space, the industry, everything you're referencing has changed so much in the past couple of decades. I truly believe if you talked about things that we know are happening now 20 years ago, they'd laugh you out of a room. Mm-hmm. It's like science fiction now. And as far as that interplay with politics, with policy, I worked almost a decade in congressional leadership in both chambers. I was the first creative director in the House and then in the Senate subsequently. And I got to know a lot of these members, to see them behind closed doors, how they make decisions and how their staff present decisions to them, recommend them, and it's interesting because it sounds so cliche. I know we talk about it, but space, even in these times, can really bring everyone together. Space can pull, as a concept, pulls upon so many strings, has so many footholds in someone's mind, in their heart, in their background. Whether you're dreaming about a legacy of Apollo and nationalistic pride, or you're thinking about it from a defense aspect or a jobs aspect, or any one of those things, it brings people together. And it sounds so cliche, but I think you mentioned it earlier when you were talking to Congresswoman Chu, right? You said, we're all people, we feel things. And that is the lesson.
My deep insight that I offered.
But that's the thing, you're spot on. Yeah. The thing I learned, people ask me all the time, I honestly don't talk often about politics with people I know, because the things I've seen, I'm like, how could I possibly boil it down to something? Because I actually know these people. I didn't just watch this on TV. But what I can absolutely say with certainty is, every person you encounter, whether it's a member of Congress, someone here in the audience, everyone in between, an A-list celebrity, we're all people who feel things. Yeah. And at some point, every one of us walked outside, looked up at the night sky with wonderment. And we can utilize that nugget of wonderment to inspire generations to come.
I want to build on that, because the overview effect is another way of saying that. And I've always felt, we've seen this at the very beginning of the space age as it was conceived of in this country, this idea, and this is the Arthur C. Clarke legacy, this is the Carl Sagan legacy, that the act of going to space or contemplating of space, just the action itself, even if you don't go there or get there, makes you better.
Yeah.
It brings out good things. And this level of earnestness, I think, is such an important counterpoint to an increasingly, I'd say, cynical society that we might be living in. And embracing that type of maybe cringy earnestness can be so good for you over time. And looking at Earth from space is possibly the best possible way to do that. I'll settle for the night sky. I'll settle for Saturn. But that experience it's what it is, I feel like you're contemplating something where you realize it's so much bigger than you, and that's actually not scary, it's actually somewhat comforting.
I think it's beautiful. I think it reminds us that every one of us are just a point in a species-wide constellation that we are progressing together. And to your point, you mentioned Carl Sagan. Carl Sagan said it, every time humanity stretches itself and turns a new corner, we receive a jolt of productive vitality that can carry us for centuries. Yeah. And those are the true, tangible spin-off effects of space travel reaching for the stars.
Yeah, I agree.
I thought you would.
We have a number of questions submitted in advance. Sarah is going to throw some out, and feel free, Sarah, to jump in on these as well. Hit me and Antonio. What do we got to answer here about what's going on in space right now, politics?
Well, something that caused us to do a show like this, but also to have so many people come out for our Day of Action and to speak out about how much space has influenced their lives is this moment in space history. And so we got this question from Joshua, who said, "It seems we're at a crossroads. The president has already said he would want to get to Mars in about the next 4 years, but there's also a potential proposal, don't panic, but a potential proposal that they might cut back on some of the science budget from the science mission by 50%. And this kind of gets to the point you were making about commercial space. Could Mars be reached by commercial space alone without the participation of NASA?"
No. No. And I'm not cheeky when I say that. I mean, commercial space wouldn't exist had NASA not been there to help it. But, and I'm not against commercial space. It's really important. But it's an understanding what commercial means in this context. Commercial is used as a tool by a public space program to do something for the nation, like going to Mars, right? That should serve national interest to do it. And the society, we love the idea of going to Mars with humans and robots. And anything we do in that should be a unifying activity, right? And if it's not a unifying activity, if it becomes something identified too much with an individual instead of a group, instead of a nation, instead of a set of common goals, not only will it not probably work in the long run, but then you take this idea that is a unifying, a bipartisan idea, and you make it partisan. And that would, to me, be one of the most profound tragedies of our modern era if we take something that is a unifying capability and decide to make that now a dividing one. And so it's... I think there's a way to do this. And I think at the end of the day, commercial space, it depends on NASA investment and other government investment to do these things. And then what we do when we do there, I think also reflects who we are. A national program is what I was asking Representative Chu, is that it owes something back to us because we're the public that it's meant to serve. And in the abstract, most extreme sense, a private industry has no responsibility back to the public. It has responsibility to its shareholders and to whatever it wants to do. And it's important that we keep that in mind as a distinction. And so I think there's great things for commercial space. It does fantastic things. But there's things that NASA does and should do uniquely. And that can't be done any other way.
We are at this inflection point. You know, the reality of the space environment, and I mean the space environment, the space industry, and its interplay with NASA, it's something that didn't exist 20 years ago, let alone 60 years ago. And so we're at a place where we truly have to square that off. And NASA right now needs that stability. They need to have that leadership and that direction now more than ever, because of course I have to think about, in terms of the next launch that may be months away or the next mission that maybe years away, that I obsess over this idea of where are we as a species 1,000 years from now. And if we haven't extinct ourselves by then...
To extinct, I like that as a word, yeah.
I like to think that this is this very special point that generations, centuries from now, they're going to look back on and wonder how we made these choices. How did we finally come together? So I appreciate the premise of the question, but I agree with Casey. This is a unifying moment. And you mentioned shareholders. Folks ask me, well, where do you draw the line between what commercial does and NASA can do? And something I say to folks that I usually apply is, I usually think of missions or functions of missions, aspects of it. What could you or could you not justify to a shareholder? I think there is a place for commercial space, and they can provide that function and that technology and that innovation in many aspects better than NASA has. Mm-hmm. But there are missions, there are goals, there are things that we strive for that we can't justify because we're going to get an ROI. Yeah. We do it for the sake of discovery, for the sake of exploration.
And for those feelings.
And that's where we are as taxpayers.
And along that vein, you were talking about NASA needing that stability and that leadership to lead us toward our goals. And one of the questions that was submitted to us by David was, is there a time frame for Jared Isaacman's confirmation hearings? And for some context, Jared Isaacman is someone who has gone to space multiple times. He was a member of the Inspiration 4 crew, which was the first all-civilian mission to space, but also the Polaris Dawn mission that went up recently, one of the first civilian missions where they opened up the hatch and he stuck his head out into space. This man is deeply passionate about outer space, and we think he may become the next NASA admin, but when will we know?
Yeah. We should ask Ted Cruz. because he's the chair of the Senate committee that will hold the confirmation hearings. And frankly, we don't know. He has been nominated. It has gone on a bit. We hope to see some sort of progress soon because NASA does need empowered leadership right now, more than ever. Do you want to weigh in on Jared? You've met him, is that true?
Yeah, Jared's a great individual. This is not to be misconstrued as an endorsement or an endorsement from Space for Humanity.
I'll misconstrue it.
Thanks, Casey. No, but again, I think when I think of Jared, I think of the inflection point we were just talking about. We're at a place where we truly have to square commercial with NASA and what we're capable of. So, but to answer your question, Casey and I, we don't have a crystal ball. We don't know. Yeah. Could be days, could be weeks, who knows?
Ted Cruz, if you're listening, we'd love to have you on Planetary Radio Space Policy Edition. I seriously would. He's a lot of interesting and important space stuff happens in Texas, and we could talk all about the confirmation process. But maybe in the next month, but we have to wait. And it's ultimately up to the Senate to decide that.
I have a personal question, which is, now that people have heard about this and the place that they're at with NASA, everything we're hoping to do, but this tenuous nature of the NASA funding, what advice do you have to people about what they can do to try to get involved, to help drive this forward, to help save that NASA funding and potentially shape that future of space exploration?
I think there's different levels for what people are comfortable with. I mean, I think the basic level is doing a version of what we're doing now, which is just talking with passion about what space is and what space can be. And knowing what is uniquely the role of NASA and what is uniquely the role of commercial and what aspects of those require the other. Anything else, if you don't have passion and it doesn't inspire something in you, it's not going to resonate in the same way. Then there are levels of, do you want to engage? We heard from 2 members of Congress today who said basically, please talk to us about space. We need to hear about space. That's a really probably important piece of information for us to consider if we can help the future of space, but literally engaging. And it's one of those things where at the moment, and you can talk about, you've seen members of Congress when they are dealing with constituent feedback, it doesn't mean they'll drop and give you exactly what they want, but it adds up over time.
It makes a massive impact. They pay attention to the number of phone calls they get. They pay attention if you say, I'm a constituent of yours. Yeah. And if you show up in person, like over 100 people did today, it makes a huge impact. Yeah. And whether you're talking to a legislative assistant or a legislative director or the member themselves, it's impactful because they want to see that story. They want to feel that emotion. Yeah. And that's really what it's about, about conveying that emotion and feeling the feels and then conveying the feels, right? For them to know, you never know. You never know when you're going to say something that's going to inspire them, stick with them, and might inspire them when they're taking a vote, they're at a committee hearing to ask a certain question, or during a markup or what have you. So truly just get vocal and don't be afraid to tell them what you feel and be consistent about it.
Their job is to represent you, but they don't do surveys, right? They depend on you telling them. And so the people who don't engage, they just don't hear you.
The squeaky wheel gets oiled, yeah.
It does. Start by listening to Planetary Radio Space Policy.
Then becoming a member of Planetary.
But I mean, you can educate you can listen to that for free.
That's right.
Just learn about how this process works. And then when you're ready, you can write your member of Congress. We have tools for that, or you can do it yourself. For those of you who are ready to really amp it up, join us at our Day of Action, which will happen next year at planetary.org/Day of Action. And then you just stay engaged with it. And you bring it, and then you share it the whole time you're sharing it with people. Because again, if they don't hear it from you, this is a whole fundamental feeling that you want to evoke. This is important, it's relevant, and it makes you feel something that you don't access anywhere else. Right? It's spectacular.
It truly does bring us together across nations, across ideologies. No matter who you are on this planet or what you believe, space is something that inspires every single one of us. And I think that's a message that really helped me feel comfortable doing this, because no matter who I spoke to in Congress, the moment you say space, they are excited.
One more thing. Space, unfortunately, is not in the Constitution. I would love it to be there. We should have a constitutional convention for that. But that means it's discretionary. It's something we choose to do. And I think some of the things you talked about, and the potential cuts, those are reported. We don't know if that's coming, but my job is to worry, right? And we can always decide not to do it. And we should never take for granted that something has been decided, period. We have to keep deciding to do it. And so deciding every year, every day, that this is something that's valuable, that's the important part.
I feel like we could talk about this subject and speak with our guests for literally the next 3 years, but we have already taken so much of your time. I really appreciate everybody in this audience for being here, because this speaks to your passion for this, whether or not you're someone who's already gone to Congress to do this, or just someone who wanted to know more about space and where we're at in this political moment with all of that. You took the moment to come out here and be here with us in this moment. I know so many of you are going to be online with us in the future as we continue doing this. Please, if you can or you have the time, we would love for you guys to become a part of our Planetary Radio audience. We've been doing this for 22 years, and we have so many more wonderful stories to tell in the future. So if you would love to become a part of this and listen to our show, it comes out every Wednesday at 8 a.m. Pacific time, 11 a.m. here on the East Coast. We're from California, obviously. And Casey's show, Space Policy Edition, comes out every first Friday of the month. You can find that at planetary.org/live. It wouldn't be Planetary Radio without our chief scientist, Dr. Bruce Betts. So before we finish up our Planetary Radio Live, here's what's up. Hey, Bruce.
Hi, Sarah. How's your glorious trip?
I mean, anytime you go to DC, it's always a big adventure, but just personally, I have a lot of family in the area, and I kind of grew up in that area when I was younger as well. So anytime I get to go back to DC, it's always a good time for me.
Cool.
But you
What are we
too.
talking about?
You also have a bunch of adventures in that city because you had to live in the area to work at NASA HQ. What was that like?
It was now a long time ago. We used to ride our horses to and from.
Really?
No.
I almost believed you.
So anyway, it was a great experience. Learned a lot about all sorts of things, from instrument development to how the bureaucracy ran, at least at that time. So it was an amazing experience, which is what I hoped for. It was kind of a pain and kind of wonderful.
Yeah, that's what's so wild about it. Like, we just got into this for the science, but now I'm learning so much about the way that science interfaces with politics in the United States and the ways that government funding really controls the opportunities for people. So while this wasn't anything I anticipated for my trajectory in life, I'm really glad that I get to go on these adventures and learn more about the process and hopefully share it with more people so it feels a little less scary to them. Well, after all of this wild adventure, I could totally use a random space fact.
Random space fact.
So nebula, we're talking about nebula, those dusty, gassy things out there. But what we're talking about is that some of them have really funny, quirky, or unusual names. And you may have heard of these, but you may not have. They're the ones that, of course, we've heard of more, like the Orion Nebula, the Crab Nebula. But what about the Running Chicken Nebula?
What?
I'm not making this up. IC 2944, constellation Centaurus, supposedly looks like a chicken in motion. Most of the astronomers, I think, were really, really tired when they came up with these names, so it's very hard to actually see this, but I suppose if you're tired and blurry, it looks like a running chicken. And if nothing else, it's just funny that we have a running chicken nebula. Two more I'll mention. The Hamburger Nebula always makes me hungry. And looks kind of like a space burger. And then, of course, you want to avoid the Rotten Egg Nebula.
Is that what the chicken was running from?
Oh, actually, I don't know which came first. Well, everybody, go out there, look up in the night sky, think about running chickens and getting away from rotten eggs. Thank you, and good night.
Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our amazing members, not just here in the United States, but all around the world. I want to thank you so much for helping us for 45 years to help shape these things. We have saved missions. We have shaped the future of what's going to happen out there, and we truly appreciate it. Mark Helverta and Ray Paoletta are our associate producers. Andrew Lucas is our audio editor. Our theme song, which you heard a little earlier, was produced by Josh Doyle and Peter Schlosser. And until we all meet again, you guys, Ad Astra.
Yeah. Let's thank our guests.
Thank you so much.
Thank you, Congresswoman Chu. Thank you, Congressman Whitesides and Bill Nye and Nancy Chabot. Thank you.
Thank you.
Thank you.